word polymorphism means many forms, and in programming, it refers to the function with the same name. You can have the same name of something like a function. It does the same thing across board. So let's say I have x is equal to hello. We know that x is a string, so I can say print len x. Let me do string, and I can say len string. Then I'll write something else again, a list, and here I will print what I call a list. Now, what do you notice here? What I'm trying to demonstrate is that there's one function that does one simple thing, and what that function does is to count the content of the object is dealing with, irrespective of the fact that the object is having different types. So len can handle string, len can also handle lists. That way means this function can handle many or different types of objects. So class has that ability for you to be able to use one function to do so many things. So look at the case where you have the student, the last example that we gave, where we have student, teacher, and then we have person. Now notice that three of them greet at some point. So it's possible that you can have a function outside that will say they should talk. And then as long as they are a person, they should be able to talk. So let's go to the assignment I gave you guys. So let's start from the beginning. So we have class animal, and by default, we have this self that automatically accepts, whatever you want to put there. This category is like, we have a category, we have leg, and then we have species. That's the type of animal. We have category. I don't remember saying anything about category. Did I say anything about category? I didn't say anything about category, but that's fine. So you can add more things if you want to. So here, this is implementing the string. The string is this right? This is double underscore, not one underscore. It's supposed to be double underscore. So it's not one underscore, it's double underscore. Did you test this your code? So this is string implementation. I also implement this. This one is double underscore, not just one underscore, double underscore. So this one is good. Immediately the class was created, you use the class immediately, which is not bad. But the problem is that you are using animal class, which is supposed to be a derived class. You're not supposed to create this animal as dog like this. You're supposed to create it calling the dog class, not calling the animal class. You will rarely be using the animal class because the animal class is the base class. You created it because you wanted to make dog inherit from animal class. That was the reason why you created it. You didn't create it for consumption like this. So this one is not needed here. Apart from the fact that it's not needed here, most of the times you are supposed to create all your classes on top. Just like when you were using functions, when I was teaching you guys functions, remember that all your functions, I told you guys to put them on top. It's for code readability. So classes are supposed to be arranged on top. So let me move all the classes on top, and then you see the difference. So now we have this class here, which is supposed to be for dog. I move it up here. And then I go to move the one for cat as well. I move it all here. So don't be in a rush to implement. First create all the things you want to create. So these are our animal, these are our dog, these are our cat. This is the template, guys. This is the template. So now that you have the base of all the things, then you can start writing your code. This is the main body of your program. All these ones are supposed to be what you will be needing, in your program. So like I said, you don't need this one. You don't need this one. This is not the proper call of what it is you want to do. So I'm going to ignore all this section and do the proper call of this program. So what I just need to do is to say I want a dog. I'll just say a dog. And since I have a dog class, now I created a dog object. So my dog object requires me to pass some information. So you can see that you won't need this category anymore. This category was not needed because I assume that this category, you are using it to specify either it's a dog or something. So you won't need this category. This category can fit into other property of an animal. Apart from the fact that you want to know the species, you might want to say if it's hairy or not. In fact, let me use name instead of either if it's hairy or not. So let me say the name of the animal. So you have the legs, the species, and the name. Now I have a dog, and the name of this dog I want to call it, so I have to use all the parameter here that was specified: name, legs, and species. So I will say the name is Snoopy. The legs, he has 4 legs, and the species XYZ. Big. Okay, so this is a dog, and the next one you can say a cat, and again you are doing what? A cat class. Cat can be, just call it cat, and I also have 4 legs, and this one is species of a cat, SPY. Okay, so we have all that sorted out. So the next thing is, so you didn't need to do it this way. So what you were doing was to use the class, the base class, to be creating this. This is what you were supposed to do. So you can see your own implementation versus what is supposed to be. Remember the teacher student example. The base class was person, and the class that we derived from person was student and teacher. So that's what is happening here. The base class is always having some features of the main class, and when we go to real life scenario, you will see how we are going to handle that. The next thing for you to do is to say, okay, this dog should be able to make sound. So when you say, did we implement anything? Oh, we didn't implement any special function. So you didn't implement any special function for this guy. So that's good. Let me now use that to explain function polymorphism. Function polymorphism is you want a function that will be able to work on any object that you want, not just any object, the object that you want. For example, len work on a string. You guys saw that we use len on a string. We also use len on a list. So I should be able to create a function that says make sound, and I can make the sound work on a dog, and I can make the sound work on a cat. Do you see? So this is me making one function work on a specific object or specific objects that I have. So let me go ahead and create this function that says make sound. So I'm going to delete all this. Just watch where the function is going to sit. The function doesn't have anything to do with our class. The function is independent. Just like the len function was not tied to any object. Did you guys notice that len is not tied to any object? It's independent. So it doesn't mean that you cannot create an independent function. You can, standing on its own. But there are some functions that will need to be derived from a class, which is also fine. So your function that you are creating, so therefore function polymorphism is a function that stands on its own that you can use to call or do anything to an object of your choice. So let's go ahead and define the function to make sound. So I come here, look at where I'm starting, guys, in the beginning. So I say def. So you can see the difference. This def is starting from here. This one is under this class. So this one is starting from the beginning. Rule of the thumb, create all your classes first, followed by all your functions, then you start your main program. Of course, if we are doing a very robust system, all these guys can be in their own respective files. This is just because we're just creating a one-page project. That's why everything is kind of here. So we say make sound. So when we want to make sound, what is this that we want to pass in? I'm just say the animal, and I'm not returning anything, nothing special. I'll just say print animal. Good thing is that we implemented the string implementation of the object, so it will just print all these things you said. So I'm gonna continue implementing it properly. So it's supposed to be double underscore. I don't think we got to this part. We just did for animal alone. So this is supposed to be double underscore. I think we are done. Okay, double underscore. Remember, this function is useless until you call it. So this is your application running. You have a dog, you have a cat. And let me call this guy list of animals. My list of animal is a dog and a cat. Do you see what's going on, guys? I put all these guys inside a list so that I can loop through it and make sound for A in list of animals, what should happen? I want to make sound. So make sound of what? Make sound of A. So what has happened here is that because of polymorphism, I can run a particular function, specific function that is tied to the object, and it will just make sense and it will just work. Yes, our first error. So let's debug these things together, guys. And you guys should be running your code, though. You should be running your code so that you'll be seeing all this error and then you know how to work with it. So the first error says that missing one required positional argument. So obviously we didn't pass all the arguments, to dog. Now this one have a special constructor when you are creating dog. For cat, its own is type, right? So this is just being able to create different scenarios. So here you can then say, okay, so we have pitbull, type of cat. It's called Siamese. Okay, so let's run these guys and let's see what we have. So in the implementation of the super, we are missing something in the implementation of the super.
Double underscore.
Okay, double underscore, correct.
Yes,
double underscore. We missed that. We missed that in all of them. Okay, double. So let's give it a try again. Okay, guys, so it's running well, giving us what we need. The most important part is how we were able to call all these guys, by itself. So this one gives us where is it here? Just to make sure that this one is just to make sure that it's giving me what I want to see. So I can see the demarcation here. So, but do you know that you can actually implement make sound inside each of the classes, and you can automatically call all the make sound from each of the classes. So instead of me calling make sound, let's look for something else. Let's say walk. So let's add the third function, and then this will be def, and I'll say walk. I'll just say working with these legs. So if we had created another one that says monkey, and this one, I don't need to specify all these guys. I just need to stop at specie and implement the super of this, so that I won't need to enter any other thing. Then, do this like this. So I can then implement the walk. Look at what I did here. I implemented the walk here in animal. Hope you know that this walk has been inherited by dog, by cat, and by monkey. So you can therefore go and do a.walk, print a.walk. So if animal can walk, these other people too, they should be able to walk. I didn't create monkey object, so let's create monkey object, guys. So I'll say a monkey. Instead of me saying cat, I'll say monkey king. It has 2 legs. I'll just leave these ones like this. Then you remember that you need to add it to your list of animal kingdom. If you run this now, so you should be seeing something different. Remember our 2 legs that we implemented there, we should see it in our report. So if you look at it, say monkey king is working with 2 legs. This is you making use of, even though it's not full polymorphism, this is making use of the ability of inheritance to inherit the power of the class. That's the base class. Now, polymorphism is when you can now call all the working method for each of the class. So I can go ahead and implement work for everybody. And again, you don't need to implement work for everybody if the same work works for everybody. The animal work that you have works for everybody. You can use that. But if you need to implement work for each of them, you can do that. And then you can just say a, that's the class or the object dot work, and it will just work. You can do the same thing with make sound, meaning you then have to implement make sound on all the objects. So your decision to either make it functional based polymorphism or class-based polymorphism is strictly based on you. You are the one that decide if you want to make this class-based or function-based.